So the first question to R is, this is an easy one, R.
Good, I like those.
Which decarbons fuel that do you think will ultimately dominate marine?
It's not that easy. I think we've heard a lot on that today, haven't we? We all know it's horses for courses, I would say. So it's interesting. In the last few weeks, I've been at quite a few marine things. There was an IMEC Marine Conference last week on alternative fuels, and the gravity there was all towards shorter term. Methanol, even biomethane for some of the vessels. So I think there's a place for all these fuels. Methanol is seen as an easier drop-in. When we talk to OEMs who make these engines, they all think methanol's an easier drop-in. It's interesting with ammonia because there's a bit of hesitance about it. So when we're talking with industry partners, a lot of them are just holding back to see if we can sort out these problems with the emissions, the safety. But as far as net zero goes, ammonia has no carbon. And it's probably cheaper to make at scale in the long run. So they all have a part to play, I think.
I agree with Al.
Good.
If I were you, I would just say all fuel has a part to play.
They do. I think the interesting one, though, is we've seen it today, heavy fuel oil, and where that goes and the timing of that.
Okay, so we move on to the next question. Thank you, Al. So the next question is for Stephen. Stephen, this is also a very easy question for you. How will the 12 UK Freeports collaborate?
Okay, well, we're doing rather a lot of that already. I alluded to the existence of the FIN, the Freeports Innovation Network. So we have a formal network where we exchange information, opportunities, common problems. But we also have, perhaps more usefully at times, an informal network. So we tend to meet roughly, bi-monthly and bounce issues off each other and make suggestions to each other. There are specific strands of activity that have emanated through support, for example, from the Department of Transport or the Connected Places or the digital or the energy systems catapults, which have led to pilot projects. So, for example, there's one on frictionless digital trade that's been advanced up in Teesside. There is work going on with the Cabinet Office at the moment around communities of trust. There are many projects, in fact, I know Joe's had to leave us, but Port of Tyne has done a lot of experimental work there. So we do transfer best practice and experience and current project opportunities between us. More importantly, perhaps, in recent days around AI. So, for example, Port of Dover, I know Meg is using a Freight Innovation Cluster alumnus company from our area called Entropy to analyse using CCTV the arterial routes going in and out of Port of Dover to allow them to minimise their stacking and thus reduce their carbon footprint in that respect. And we're also working with a Cambridge spin-out called RoboK on reducing health and safety infringements by using, again, employers' own CCTV systems in ports, following a very successful Port Safety Committee pilot project in Port of Bristol. That's now being rolled out into not only Port of Dover, Port of Portsmouth, but also warehouses and large logistics facilities. So there are lots of really exciting breakthrough technologies being experimented with, and we are sharing the knowledge between us.
Thank you, Stephen. I believe the colleague who asked this question is the one who is very keen to become the next Freeport. Reach out to Stephen and learn. Ask Stephen to share his lessons, how they actually made their port a Freeport. Yeah. Okay, so I have a very technical question for Pietro. But Pietro, please keep your response short.
I knew I was about to pick the difficult one.
Okay, so Pietro, what modifications to the power systems are required to accommodate large-scale energy storage on vessels?
Yeah, well, I think this is pretty much a matter of research right now, because, as I said, when you talk about large-scale batteries, we are pretty much thinking about the traditional AC medium voltage systems. So when you have a big battery, you need to go up with the voltage level as well, because higher power means higher current. If you want to keep the losses low, you need to increase the voltage so the current is low. So, that means pretty much the only option available nowadays with medium voltage AC system. They talk about 6.5 kilovolt, 11 kilovolt for very large ships. And that creates a host of problems because the battery is DC and the power system is AC, so you need the inverter, the filters, and all the stuff that you need to get rid of the problems caused by the converter. So there are studies thinking about medium voltage DC, so it's the same type of electricity of the battery. But pretty much the technology is not there yet because the voltage level used in ships today are up to 1,500 volts, which is much lower than the 11 kilovolts, so it's 10 times lower. It's about developing that technology. But this is actually in the process of being researched and studied. And right now, I'm also doing a project on this, on medium voltage DC ships, where the aim is to increase the voltage at least to 3 kilovolt, maybe 6 kilovolt, because that would be enough to get megawatt scale for the battery, as well as increasing the voltage of the battery, which is not that easy. It causes another set of problems, but this is probably for the next question.
Yeah. Which can be further elaborate, not now, by emails, please. Okay. So I have a question for Megan here. Megan, in your work, what assumptions did you make for berthing time, travel times, and other parameters? If you could keep your response brief.
Yeah, so for almost all the work in the CMDC2 project, we just used the hybrids and kind of ramped those up as if they were fully electric. At the time of the project, the FDS had told us they were going fully electric, but they weren't willing to share any specifics on the vessels because it was so at the start of that journey. So the best available information we had at the time was to use that hybrids. One of the things that University of Kent made, I'm probably going to not explain this very well from a technical point of view because I'm not an engineer or a professor or anything, but they made this model whereby we can change all the information. So we have the ability to input what's changed about the vessel, so whether that's how much it needs, the length of time, the number of vessels, what make of those vessels, and it will spit us out a new duty cycle and therefore the costs and the amount of batteries needed and all of that kind of stuff. So we've been using that a lot lately. As and when we get more information from the ferry operators drip fed to us, we can put that in and get some new information because, as I said to you already, so many of the things on that last kind of timeline slide have already changed, and I imagine they'll change again, to be honest with you.
Okay, thank you, Matt. So my question for Angad today, the first one, okay. Thank you for presenting your very insightful experimental work. So our audience wants to hear from you about the real-world challenge that you face in conducting your research. Because the way you present it seems so impressive and seems like it's not really a big challenge to you.
I think there are two kind of aspects to this, which is it's only over the last 2-3 years that there were some really fundamental questions that were not answered have actually been answered regarding the overall engine architecture of optimizing the different setups and so on. The one benefit which is there is that because we utilize nearly about 80% of the standard engine components, the understanding of how to utilize that exists. The reason why it is kind of not necessarily on the market that you can go and buy a split cycle type of engine architecture is that those 20% of components that need development, intake valve needs to be changed and so on, a recuperator needs to be mass produced. Those are the things where actual OEMs need to actually step in and recognize that there is a gap in market, especially if you can make a good recuperator. It doesn't matter if you utilize that in split cycle engine architecture or a standard engine configuration, you will actually have a market down there. Yeah. So I think there's a 20% kit which needs a bit of experimental development, proving the durability over 10,000 and beyond hours, which is actually not there yet.
Okay, thank you, Angad. So we have one common question for all our speakers as our last questions. Do keep your question and your response to one sentence, if possible. Okay. So the question is like this: Communication and collaboration across sectors seems to be a key theme today. Can our UK MRS hub play a useful, convening role in this?
I've got it first by the looks of it. I think that's a really good point. Off-road, aerospace needs certain biostock. It all needs to be considered together for the UK for sure. So the networking through, that's really important.
Thank you.
I'll leave it there.
In a word, yes. I think the hub's already doing it. It started doing it at the very first informal gatherings, and it's continued to take a very strong lead in that since. And as I mentioned earlier, we've been able to generate, I think, in excess of 7 million in only the last 9 months successful funding from collaborations that came out of the hub. And we're very proud to be a member of it, and we keep encouraging others to engage with it. And I'm sure that other members of the audience will be doing the same within their organisations and their networks, because the more extensive it is and the more it deep dives into different aspects of the technological challenges we all face, the more we're likely to make progress.
Thank you.
Yeah, I fully agree with that. I think the maritime sector can be considered a system of systems. So I think interdisciplinarity is key here. So we are going to see moving the sector from something traditionally dominated by mechanical engineering, but now there will be many more professionals in many other different disciplines. They will definitely play a key role in achieving that transformation.
Thank you, Pietro.
Yeah, I agree with everything that's been said. I think we've heard quite a few times that ports aren't even the best at talking to other ports, and ports aren't the best at talking to the vessels that come there. So there's already plenty of space that needs to improve there. So things like the hub are doing a brilliant job of, and all these different kind of CMDC projects are doing such a good job of actually bringing all of that together. I don't think we would have made any of the advancements we have without that kind of stuff.
I think I could just kind of echo the same thing, but from a slight technical perspective, the level of knowledge sharing that is actually happening, and realizing that a few years ago somebody would have said that, somebody would have else said you have lost your marbles, but now somebody has actually proven in the lab that it's actually doable. Recognizing that within the hub and the partners around this, what they are doing is really at the forefront of work. I think that itself is so encouraging that we all need to kind of tap and build up from that.
Yeah. Thank you, Angad.